Hello class, today we are going to be learning how to find the sum of the interior angles of a regular polygon, actually of any polygon. And then we're going to find the measure of each interior and exterior angle of a regular polygon, and of course the sum of the exterior angles. That's the easy one. Okay, let's begin. So first let's talk about what an interior angle of a polygon is. Well, if we have two sides, then this is an interior angle. This is an interior angle, as are all of these. Notice that this is a pentagon. My word got hole punched out. Pentagon has 1, 2, 3, 4, 5 sides. That means it has 1, 2, 3, 4, 5 points or 5 vertices. And then at each vertex is an angle. So there are 5 angles. So whatever number of sides there are, it's the same for angles. Moving on. So now, here's your formula. The sum of the measures of the interior angles of any polygon is 180 times n minus 2. That's what you're going to do. N is your number of sides. And that's what it says right here. Okay, so let's check out example number 1. Find the sum of the measures of the interior angles of an octagon. Okay, well, octagon means 8 sides. So n is equal to 8. Here's your formula up here. 180 times 8 minus 2. So plug it in our calculator. So on 180 times, well, n minus 2 is just 6, so type in 6. 1,080 degrees. That is the sum of all of the interior angles, number 2. What's the sum of the interior angles of a pentagon? Well, of course, we know that's 5 sides. So 180 times 5 minus 2. 180 times 5 minus 2 is 3. I just do the baby math in my head. 540. 540. Ah! I knew that was going to happen sooner or later. There we go. So then we want to move on to that last thing that they're saying on this page. Okay, so now we know how to find the sum of the interior angles of a polygon, but if we take that polygon and we make it regular, then that means that all of the angles are going to be the same. Well, if we know that all of the angles are 180 times n minus 2, and n is the number of sides, which is also the number of angles. So if there are n angles, and we have all of these degrees, we want to divide it evenly between all of those angles. So this is the measure of each angle, each interior angle, because that's what we're talking about here, each interior angle of a regular polygon. Let's check that out. This side over here. Number 3. Find the measure of one interior angle of a regular nonagon. 9. So now I know I have 180 times 9 minus 2. Because my formula, you can write it on top. 180 and minus 2. That's all of the angles added up. This is the sum of all of the interior angles, but I just want 1. And since there are 9 of them all together, we're going to divide by 9. Let's just plug it into our trusty calculator. Whoops, 180 times, okay, that's 7, divided by 9. 140. Twice, 140 degrees. If the sum of the measures, number 4, of an interior angle of a polygon, how many sides does it have? Let's start off with the formula. If you remember, we wrote sum is equal to 180 times n minus 2. So if you write out the entire formula, there are actually 2 unknowns. Given the number of sides, we can find the sum. But if you're given the sum, plug it in here, and you can find the number of sides. So let's see. So we're going to say, well, we know that that's 180. I'm sorry, 1,800 is equal to 180 times n minus 2. Two different ways we can solve this. I'm going to do it two ways. I'm sorry. Let's get back to sleep. N minus 2. Okay. $200 is equal to 180 n minus 2. There. That's it. The first way, and this is how I actually solve them, here I am multiplying two things. I am going to divide by 180. To me, that's just easier. I'm going to divide over here by 180, and I'm left with 10. 10 is equal to n minus 2. Add 2. That's 12. So n is equal to 12. If you don't like that way, totally fine. And then we can go over here and we can actually distribute. 1,800 is equal to 180n minus 360. Add 360 to both sides. 60. $1,800 plus 360. That's going to give you 2160. Then we have to divide by the coefficient of n, which is 180. Divided by 180, it's sitting there in the calculator. Oh, look, there it is. N is equal to 12. So you can solve it doing the algebra either way you want to. N is equal to 12. This question says, how many sides does the polygon have? If we are careful, we have to be careful when we read, because maybe it asks, what's the name of the polygon? If it asks for the name of the polygon, then go back to the table that you did in your previous notes, and you know that this is a dodecagon. Okay. If they ask for the name. Moving on. So now, practice on our own. You could pause and try these, but I am going to do these quickly. 23 gone. So we want to find the angle sum for each polygon. So that's our 180 times n minus 2. I'll plug that in the calculator in a moment. This one has 6 sides, so it's 180 times 6 minus 2. 180 times 21 and 180 times 4. 720 and 3780. Degrees, and we're good. Okay, find the measure of one interior angle, so we have to know if it's regular. Okay, so this one they said regular, this one wasn't marked. Should be marked, so we can mark it really quickly. But it has to be regular in order to find the one. Okay, so now what we're going to do is say, okay, well, 1, 2, 3, 4, 5 sides, right? So it's 180, 5 minus 2. That's our basic formula. Divide by the number of sides. Over here, 180 times 19 minus 2. Divide by the number of sides. 180 minus 3, times 3, divided by 5. 108. And over here, 180 times 17 divided by 19. 161. Oopsie, sorry about that. Okay. Next up, here's the last guy. If the sum of the measure of the interior angles is this, how many sides does the polygon have? Okay, well here we go, sum again. So now my sum is 1980, so 1980 is equal to my 180 n minus 2. So it's equal to the formula, and n is the number of sides. Me, I like to divide by 180. So 1980 divided by 180. And that's 11 equals n minus 2 plus 2 plus 2, 13. N is equal to 13. Okay, so just know when you do a problem like that, whenever you divide, so here I'm dividing by 180, I have to get a whole number. If I don't get a whole number, then I don't have a whole number of sides, and that wouldn't make any sense. Okay, let's move on. Next one. How long is this so far? Oh, 10 minutes. Okay, we're good. I have another page, and I lost it. Oh, it's on the back. Okay. Let's keep going. This is easy. It's short, it's simple, just remember it. Exterior angles of a polygon. Okay, so this is how we find an exterior angle. Here is your interior angle. If you extend a side, then you get two supplementary angles. One of them is the interior angle, the other one is an exterior angle. So that's an exterior angle. So to find, here's an interior angle, we can extend either this side or we can go up this way and extend here. The exterior angle is going to be the other one here that makes a straight line. These guys are supplementary. So this is your exterior angle. Just note, your interior angles and your exterior angles are supplementary. Okay. Here we go. If we add up all of those exterior angles, one from each vertex, that sum would be 360 degrees. 1, 2, one of them from here, this one, and then of course one more down here, whatever that is. That is going to all add up to 360 degrees. If it's regular, then the measure of each exterior angle of a regular polygon, we're going to take our 360 degrees and divide it by the number of sides. The total of 360, if it's regular, share it evenly. And n is equal to the number of sides. That's what it's always going to be for this small unit that we're doing. Okay, so now we want to know the measure of one exterior angle of each regular. Okay, they have to be regular polygons. Well, let's see, 1, 2, 3, 4, 5, 6, 7 sides. So 360 divided by 7. Quadrilateral means 4 sides. 360 divided by 4. Well, that one we can write in, we know that one. 23 is our total number of sides, so 360 divided by 23, and 1, 2, 3, 4, 5, 6, 7, 8. 360 divided by 8. Pull out the calculator, we'll do these lickety split. 360 divided by 7. 51.4 degrees. 1 decimal place is sufficient. 360 divided by 23. 15 point, we got a round, right? 7 degrees. And then our last one, let's do 360 divided by 8 and get 45. Okay, there we go.